Hello, today we're going to work on the atoms basic worksheet. We're going to start with part A. This should be reviewed by now. So we're going to drive 5 protons in the nucleus of this atom, and we're going to label them with our charge. So this is an atom, and today we're going to explore it further. So number 1 says draw 5 protons. So we're just going to go ahead and put 5 circles, and we're going to identify them with their charge by putting positives. I'm going to use different colors. You can still keep the same color. So number 2, we're going to draw 6 neutrons in the nucleus of an atom. So if you have any questions or you don't know which are neutrons, this has the root neut. So you might also know this root word in an example such as neutral. It means none. So there's no charge for neutrons. So we're going to go over here, we're going to put 6 neutrons. Alrighty. Number 3, we're going to draw 2 electrons in the first energy level, and we're going to label them with their charge. So if this is the nucleus, this is going to be the first energy level. We're going to draw 2 electrons, and they're labeled with their negative. Next, we're going to draw 3 electrons in the second energy level, and we're going to label them with their charge. So whenever we do this, I'm going to start preparing you for your expectations when you take chemistry in high school. So whenever you are drawing an atomic structure, we put the the electrons in a certain system. We go north, south, east, and west in that order. So you see I did that here. Okay, so back to the problem. We're going to draw 3 electrons in the second energy and label them with their charge. So 1, 2, 3. So what element is represented by this diagram? If you look at a periodic table, there are 1, 2, 3, 4, 5 protons, and there are also 1, 2, 3, 4, 5 electrons. So if you look at any periodic table, the atomic number of 5 belongs to boron. Alrighty. Next, we're going to do the atomic calculations. First, we're going to label the information provided. So by now, we should know that this number up here is equal to the atomic number. This here is the element symbol. Or the chemical symbol. This is the element name. Finally, this is the atomic mass. So we should be able to recall that atomic number is equal to the number of protons. And protons begin with P, so the charge of protons are positive. So think of a magnet. If I have a magnet, one side is positive, what's the other side? The other side's going to be negative. So just like I have a positive here, I'm going to have equal proportions of negative, because think like a magnet. And the negative subatomic particles are electrons. So that is this number. The atomic number is equal to the number of protons or electrons. Down here, the mass number. So what does the atomic mass represent? Well, this is the atomic mass. So you want to go back to, well, what are the 2 subatomic particles that have mass? The protons have a mass of 1 atomic mass unit, and we know the neutrons have a mass of 1 atomic mass unit. And if you recall from your foldable, electrons have an atomic mass of 1 divided by 1800 AMUs. So we basically consider this having no mass. So the 2 subatomic particles that have mass our protons and neutrons, or we make up the mass number. So protons and neutrons. Now we're going to use this information to answer these questions. So how would you find out the number of protons or electrons? That goes up to here. Protons or electrons are represented by the atomic number. So you would simply look at the atomic number. Alright, so now we want to figure out how many the number of neutrons. Here's where we're going to do some math. If I know my atomic mass is equal to protons plus neutrons, and I subtract my atomic number, which is equal to the protons, that would give me neutrons. So let's do this way and another way. If my atomic mass is equal to my protons plus my neutrons, and I need to get neutrons, I can take P plus N, and if I take away P, it would give me N, right? So let's go back to what we know from over here. P plus N is the atomic mass. So if I take the atomic mass and I subtract out the atomic number, which is the number of protons, this would give me neutrons, which is what we will need. So how would you figure out the number of neutrons? You would take your atomic mass, subtract your atomic number, and that'll give it to you. So now we're going to use our knowledge of the atomic calculations to complete this chart. Hopefully we'll see some trends along the way. So lithium has an atomic number of 3, a mass of 7. Therefore I know that the atomic number is equal to the number of protons and the number of electrons. I know this number is going to be the same as this number and this number. So now I need to do some math. How to get how many neutrons? Well, to get neutrons, I'm going to take my atomic mass minus my atomic number. So for here, I'm going to take my mass. 7 minus 3 is 4. Moving on. P, I have an atomic number of 15, an atomic mass of 31. Protons, I know the protons are the same as the atomic number, so this will be 15. If I have 15 positives, I'm also going to have 15 negatives. Now I need to figure out neutrons. Again, I'm going to take my atomic mass of 31. I'm going to mass out my 15, and I have 16 neutrons. Next I have Cl. I know my atomic mass is 35 and there are 17 protons. The fact that there are 17 protons, I know that they're all the atomic number is 17. If the atomic number is 17, the protons are 17. I know there's 17 negatives. To get the neutrons, I take my mass minus my protons, and that gives me that. So 35 minus 17 is 18. Ni has an atomic number of 28, so I know that this number is the same here, and it's the same here. Now these two added together would give me that. So 31 plus 28, I know will end with a 9 and a 5, 59. K has a mass of 39 and 19 electrons. If it has 19 negatives, I know it has 19 positives. And if it has 19 protons, that's also the same as the atomic number, 19. So now I have 39 mass, 19 protons. So if I take my mass minus my protons, that'll give me my neutrons, because this is protons plus neutrons minus protons. So 20. Ag has an atomic number of 47. I don't know its mass. I don't know its protons or its electrons. I know my atomic number plus my neutrons would give me my mass. So if this is 47 atomic number, that's the number of protons. If there are 47 positives, there's 47 negatives. And then my protons plus my neutrons are the same thing as my atomic mass. So add those. 61 plus 47. I know it's going to end with an 8. 108. Next we have H. It has an atomic mass of 1. If it has one proton, that's the number of the atomic number, and that's also the number of the electrons. If the mass is 1, that's 1, so 1 plus what gives me 1? 0. Si, it has 14 neutrons and 14 electrons. If it has 14 negatives, I know it has 14 positives. If the protons are 14, I know the atomic number is 14. So if I add these two together, it'll give me this. So add these, and it ends with an 8. 28. W, it has 110 neutrons and 74 protons. If it has 74 protons, I know it has 74 electrons, and the atomic number is also 74. Now to figure out the atomic mass, I have to take the protons plus the neutrons, so it is 184. And finally, Ne. Ne has 10 electrons and 10 neutrons. If it has 10 negatives, it has 10 positives. If the 10 protons are also the same as the atomic number. Once again, neutrons plus protons give me this, which is 20. Alrighty, turn it over. This is where we're learning today's new information. The rest has been a review. So today we're going to learn about electron configurations. There's this rule in chemistry that applies to you, but it won't apply to you if you take higher level chemistry classes. But for now, this general rule works. It's called the octet rule. And because of this octet rule, certain things apply. So you might know by the prefix oct, it might have something to do with 8. And that is correct. So this is the way that electrons kind of revolve around the atom. So they have these energy levels. So that's how where the octet rule comes. And how many electrons can each level hold? The first shell is very close, so it can only hold 2 electrons. The second shell, it's called the octet rule, can hold 8 electrons. And the third, likewise, 8 electrons. What term is used for the electrons in the outermost shell or energy level? Those are called valence electrons. So whenever we talk about valence electrons, we're talking about the ones in this outermost shell. So now scientists use two diagrams to show the electron configuration of atoms. So you're going to follow instructions to complete this worksheet. So we know sulfur has an atomic number of 16. It has 32 atomic mass, so its protons is 16. It has 16 neutrons, therefore 16 electrons. We're going to use this information to illustrate a Bohr's diagram and a Lewis structure diagram. Go ahead and bring some attention to this. This is important information. So for the Bohr's model, we show all of the electrons, whereas the Lewis structure, we only have the valence. Remember, the valence are only the electrons in the outermost shell or energy level. Okay, so whenever we do this, we think of electrons as money, because I know that you guys have and know how to use money. So we have 16 electrons, or say $16. And according to these rules, we can only spend 2 electrons, or $2, in the first store, or energy level. So whenever we do this, we're going to follow our northeast-southwest pattern. 1, 2. So I just spent 2 electrons, or $2, so I need to go back and recalculate my money. So I have 16 I started with, and I just spent 2 on the inside level. I have 14 electrons left. According to the octet rule, in the second shell can only hold 8. Here's where we're going to do it again. North, east, south, west. There's 4, so now we're going to double them up. 5, 6, 7, 8. I just spent 8 more electrons, or $8 more. So how many more do I have left? 6. I have 6 more electrons. So go ahead and put them in. 1, 2, 3, 4, 5, 6. So I'm all spent all my electrons. So Bohr's has all of these structures, all of these energy levels. So if you get a bigger atom, you might be drawing for a lot of time. So that's where Lewis structure comes in hand. They only show the valence electrons. So if you refer back to here, there's 1, 2, 3, 4, 5, 6 valence electrons. That's the only thing we're going to put here. 6. Alrighty, we're going to continue to practice. Lithium has an atomic number of 3, a mass of 7, therefore has 3 protons, 3 neutrons, and 3 electrons. Let's get our accounting up. I have 3 electrons. According to the rule up here, the first can only hold 2. 1, 2. I have 1 electron left. 1. And remember, the Lewis structure only has the valence, which is 1. And you are finished. The next one is Ne. It has an atomic number of 10, a mass of 20. Therefore, I know it has 10 protons, 10 neutrons, and 10 electrons. Let's get our accounting up. I have 10 electrons. According to the rule, only 2 can be spent in the first shell. How many do I have left? I have 8 left. And that goes north, east, south, west, north, east, south, west. Now when I do the Lewis structure, I only have the valence, the outside. 1, 2, 3, 4, 5, 6, 7, 8. That is neon. Moving on to Mg, it has an atomic number of 12, a mass of 24. It has 12 protons, 12 neutrons, 12 electrons. Let's get our accounting up. If I have 12 electrons or $12, I can only spend 2 electrons or $2 in the first store or valence shell, or outside shell. 1, 2. How many do I have left? I have 10 electrons. How many can I put in the second shell? 8. North, south, east, west, north, east, south, west. I just spent 8 more. I have 2 electrons left. North, east. The Lewis structure is just the valence, north and east. Let's go here. Cl has an atomic number of 17, a mass number of 35. It has 17 protons, 17 neutrons, and 17 electrons. Let's do our math. I can spend 2 in the first. 1, 2. I have 15 left. I can spend 8 in my next. 1, 2, 3, 4, 5, 6, 7, 8. I have 7 left. 1, 2, 3, 4, 5, 6, 7. The valence is the only thing I care about for the Lewis structures. So it's 1, 2, 3, 4, 5, 6, 7. Keep on going with helium. Helium has an atomic number of 2, a mass of 4, it has 2, 2, 2. And I know that 2 go on the first shell, and then the Lewis is simply the valence, which is the outside, which only has 2. Finally, here's Si, has an atomic number of 14, a mass number of 28, therefore has 14 protons, 14 neutrons, 14 electrons. Here's my math. I can spend 2 in the first shell. After I spend my 2, I have 12 electrons or $12 left. I can spend 8 electrons in the next shell. There's 4 and 8. I now have 4 electrons left. Put those on my valence.